know that many of them will have a lot of confusion in the cube sums. So now we are going to clear all our doubts by a simple trick. So this is the common circuit for all the cube sums. So first they may ask the resistance between the A and G. So if they ask the resistance between A and G, you should put A and G here, then all the numericals in the up. So this then the second step is that you need to find how many resistance are between the A and B. How many resistance are there? There is only one resistance there. So just put 1. Then you should see how many resistance is between the G and B. G and B, you may see there are 2 resistance. Like that way you should fill all these things. Then you should see which of them is in symmetry. So you may see that B, D, E are in symmetry, then C, F, H are in symmetry. So you should put 4 points in the diagram which is in straight line. A, B, D, E, C, F, H, and finally G. The A and G should be in last, because you are finding between A and G only. So A, B, D, E. So from A, the B has 1, D has 1, and E has 1. So there are 3 resistance. So put these 3 resistance in parallel. Then B, after BD, there is a point called CFH. So you should find how many resistance are between the E and CFH. A to C, there are 2 resistance. Like that way, A to F, there are 2 resistance, and A to H, there are 2 resistance. So totally there are 6 resistance. Put all the 6 resistance in parallel. Like that way, A to G, there are 3 resistance namely. So put these 3 resistance in parallel. Then afterwards it will be a normal calculation. Then next we are going to see about the resistance between the A and C. So as I told that, put A and C here, then all the numericals here. Then it will be very easy to find this out. Then what means you may find the symmetry between BD and FH. But in the previous sum, we may see that there are only 2 groups, and 2 groups are in symmetry. But here there are 2 groups, and there is a remaining 1 group. So if this like this way it came, then you should put the BD up, then FH down. Okay. Then you see that near to BD, what and all there. So near to B, there is A, and near to D there is A. So the A is common between B and D, and also C also is common between A, B and D. So put A here and also C here. You may see that there are 2 resistance between B, D and A, and 2 resistance between B, D and C. You may put like this. And also you may, like the previous thing, you may put FH, then E and G. There are 2 resistance. Between BD and FH, there are 2 resistance which are in parallel. Then you may solve it very easily. And thus they are asking about A and C, right? So you need to say symmetry. So symmetry, it is symmetry about perpendicular bisector, right? So remove this perpendicular bisector and put as usual. Okay. Then AB. Then AB is also same as it is. In AB, there is a sum. Okay. Effective resistance between A and B is 7 by 12. If R is equal to 1, effective resistance between same 2 points when the link between A and B is removed. So if the link is removed, it's very easy to solve it. You solve it out. And this sum, in the sum, they try to confuse us. Okay, but this is not a cube sum. This is not a 3-dimensional sum. This is a 2-dimensional sum. Because there is no resistance between these things. It is like a cube. It is not a cube. It is like this circuit. Okay, you may put this circuit like this. You may see this square, then also this square. So there are 2 square connected. Okay, and they are asking what is the current in this resistance. So we know that it's V. That means this V will be V is same throughout this 6R, 6R and R. We know that this 6B is same for 6R, 6R and 6R. And also you know that I is equal to I1 plus I2. So first find out R equivalent, then I is equal to V by 3R and I2 is equal to 6 by 6R. From this you may find out I1. That's it.